welcome to another Router Gods video. My name is Humphrey Chung, and we're going to do OSPF manual summarization. We're going to use Practice Topology 5, and OSPF is already set up on our three routers. We've got router 1 and the left side of router 2 and the loopback in area 0, and we've got the rest, the right side of router 2 and router 3 in area 1. We're also going to add two loopbacks over here, a loopback 10 and loopback 11, 4001/32. Loopback 11 is 4002/32. We're not going to add any more loopbacks after that, but as you can imagine, if you can use your imagination, there's going to be later on a loopback 12, loopback 13, so on. So it will be something like 4003, 4004, and so on. Okay, so what we want to do is we actually don't want to see all these loopbacks in the routing table of R1. We actually want to scrunch them down into a single LSA or a single entry in the routing table. Okay, so first let's add our loopback. I'm going to go to R3 and we're going to go in loopback 10. IP address 4.0.0.1, and that is a /32. In loopback 11, IP address 4.0.0.2. It's also a /32. Exit out of there. Let's do a show IP int br. So we've got loopback 10, loopback 11. That looks pretty good. And because we've got, if I'm going to do a show run here, we're doing the Hail Mary OSPF network statement of all zeros. There you go, all zeros. And you can see there that if you do all zeros and all zeros, it's going to change that second set of zeros to 255, which is not a problem. So we're going to go to R1 and you'll be able to see the separate entries of these loopbacks. So we're going to do a show IP route. And you can see right there, these are inter-area routes. We've got two entries, 4001, 4002. And we can ping all the way over to loopback 10 on router 3, and everything's good. Okay, so the problem here is that, okay, with two loopbacks, it's not a big deal, but if we kept on adding loopbacks, our routing table is going to be huge. And we might not necessarily want to know about all that information, because what's going to happen is if router 3, if one of those loopbacks goes down, that signal is transferred all the way to router 1. It causes router 1 to update its routing table, a lot of processing power, and it doesn't really matter because the only way for router 1 to reach router 3 is through router 2. So we want to do a couple commands, actually one command on router 2 that's going to take all of these loopbacks, all of these links, and summarize them down into one address. And this is called manual summarization because we actually have to type it in. And if we do it on router 2, actually we can only do it on router 2 because it is the ABR in between the two routers. Okay, this is an OSPF thing. You have to do it on the router in between the two areas. And this is accomplished using the area range command. We're going to go to router 2. Go to router 2. And we're going to go into conft router OSPF 1 area range, do a question mark, area 1 range. So this is the area where your links are, where they're starting at. So area 1 range, IP address to match. So we want to match everything starting with 4 space question mark, IP mask, and let's make this a /8 because we are assuming that we're going to be making networks later on. So 400.3, 400.4, we're going to go all the way up to 400.255.255.255, right? Or actually it would probably be 254. Okay, so we want to start basically match everything with 4. That looks pretty good. Hit enter right there. So what's going to happen now is it's going to make another LSA with an IP address of 4.0.0.0. And let's see if this transferred over to router 1. Going to go over to router 1. So before, when I did a show IP route on router 1, we had this information, 2 entries. Now if I hit the up arrow show IP route, you can see those 2 entries have disappeared. They are replaced with this summary entry 4.0.0.0/8. Well, let's see if our ping works. Ping 4001. It definitely works, so we have connectivity. Ping 4002. And that also works. Life is good. Okay, so we have saved ourselves a little bit of routing table stuff, and that we're also saving ourselves some processing power, because if those loopbacks go down on router 3, router 1 doesn't necessarily have to know about it. All it knows is the summary address. Let's go over to router 2 and see what happens, or see what entries were made in the routing table. Show IP route. And you can see here on router 2, it made a summary. And the summary is interesting because it goes to null 0. And what that means is if it doesn't match the more specific routes, in this case 4001 and 4002, then that traffic is dropped. And this is to prevent loops. So if we go on router 1, and we do a ping of 4003. There is no 4003 over here. But that null 0 route is going to catch this, and we're going to come back with a U, an unreachable. So our pings go out, but they hit router 2, and those pings are then dropped. Okay, let's see how this looks from a database perspective. So I show IP OSPF database, and you can see here this is the summary network link state. It's created by router 2, and all it shows is 4.0.0.0. So it's a single LSA. And you can see the magic here. If I go back to router 1, or not router 1, but router 3, let's move router 3 into the picture. Let's just start making loopbacks. So conft int loopback 12, IP address 4003, it's a /32, int loopback 13, IP address 4004, it's a /32. Of course we could keep on going, but I think that is enough. Let's go back to router 1. Hit the up arrow, show IP OSPF database. Notice we still have a single entry in the database, a single summary LSA. And if we do a show IP route, we only have that 4.0.0.0 route /8. So even though we have 4 loopbacks over here going into OSPF, we still have just a single entry in our OSPF table over here on router 1. And if we try to ping the other side, ping 4003, we have a successful ping. Ping 4004, everything's good. Let's take a look back on R2. This is R2. Show IP route. Okay. So on R2, R2 knows everything. 4001, 4002, 4003, and 4004 is up here. It knows everything because it is seeing it from the right side of the network instead of the left side, which is after it has been summarized. Because you have to remember that router 2 is in the middle, so it knows everything for area 0 and area 1. And that's also reflected if we do a show IP OSPF database. we're going to get the information for area 0. That's area 0. But as we hit space, we could see that we have the LSAs for area 1. And everything is as it should be. Okay, so that was a quick and easy video about manual summarization. Just remember, it is done on the area border router. In our case, it is router 2, which is in between area 0, or connecting area 0, and also area 1. In a future video, we're going to do stub routes, or stub areas, that will make this summarization automatic. Thanks for watching.